When we use non-stationary variables in regression analysis, it's likely for us to have the so-called spurious regression problem. Put it in plain English, it is likely for us to obtain some seemingly very significant regression result, but in fact, the variables are not related at all, and the relationship that identified are actually false or at least superficial. So I have an example on the slide. I have RW1 and RW2. Here, RW stands for random walk. And I simply just used my computer to generate two random walk, two non-stationary time series. Then I plot them. And incidentally, they move in the same direction. And the pattern looks like they are following each other. And if in the second chart, the right-hand side, there's a scatter plot, and it shows a very strong positive correlation. If I run a regression model by using RW1 as the dependent variable and RW2 as the independent variable, I have a linear regression model with a significant coefficient estimate, and the R square is as high as 70%. So on all measurements, on all aspects, this is a good model. However, the results are completely meaningless or spurious, and the apparent significance of the relationship is false. Why is that? Because I told you already, those two variables are randomly generated. They're meaningless. Those are just numbers, and they happen to be correlated. It looks like they happen to be correlated with each other. If you have this type of non-stationary variables as shown on the previous slide, so they are obviously not stationary because their means change over time. And we have some tests to check formally whether they are stationary or not. If you have non-stationary variables in your regression model, even if the results are significant statistically, the estimator and predictors might not be reliable. They don't have their usual properties because the relationship actually is false.